Hello all, welcome to Code Hub. Today let us solve the Lead Codes daily challenge and the problem is online stock span. Design an algorithm that collects daily price codes for some stock and returns the span of that stock's price of the current day. The span of the stock's price today is defined as the maximum number of consecutive days for which the stock price was less than or equal to today's price. Okay, for the today's price, the previous stock's price should be less than or equal to, and we have to find the consecutive number of prices which are less than or equal to today's price. That is what the problem states. As you can see for this example, let us try to trace this example, then it will be a clear understanding. So this is our example. As you can see, for when the stock price is 100, there is only one thing which is less than or equal to between the previous, that is 100 itself. So 1. For 80, there is only one price which is less than or equal to 80 for the previous stocks, that is also 1. For even 60, there is only one thing which is less than or equal to 60 for from the previous stocks, that is 1. And for 70 there is 2. Why so? 70 is less than or equal to 70 and 60 is also less than or equal to 70 and 80 is greater, so these are the consecutive prices that is less than or equal to 70, so we have 2 here. And for 60, the number of prices that is less than or equal to 60 is only 1, which is consecutive, that so we return 1. And for 75, the prices which are less than or equal to 75 are 75 himself, and then 60, then 70, then 60. And when it goes for 80, it exceeds 75, so the total price which is less than or equal to 75 is 4, so we return 4. And for 85, the total price which are less than or equal to 85 is 85 he himself, and then 75, 60, 70, 60, 80. And when it goes for 100, it is greater than, so we return a consecutive which is 6. Total number is 6. The total number of stocks which is less than or equal to 85 is 6, so we return 6. So hope you understand the problem and what it states. So this is what the example 1 also states. So we have to return this price, and what are the constraints? So there will be 10 power 5, 1 to 10 power 5 range price, and at most 10 power 4 calls will be made to the next. So if there is 10 power 4 calls next, and we are trying to traverse each time to find the consecutive days, then obviously what it happens is there will be a huge time limit exceeded, because 10 to the power into 10 to the power 4, it becomes 10 to the power 8, and this will be an n square for this function. So we want to optimize this approach. We want to optimize the time that we take to call this next function. So let us try to think a little bit. If you carefully observe, for each and every index, we try to find the next greatest, that is the next greatest stock which is at the left hand side, that is previously given. So for the 70, the next greatest element is nothing but 80, and which is at the index 1. So we can try to represent this as index. So the 100 is at 0 and the 80 is at 1, 2, 3, 4, 5, sorry, 4, 5 and 6. So for this particular index, the next greatest element which is at the index 1, so obviously the current index is nothing but 2 minus the next greatest element which is at the index 1, so plus 1. We are dealing with zero based indexing, so the answer becomes 2 here. Let us consider this case. For this 60, the next greatest element which is at the index 3, so which is at the index 3, So the current index is nothing but 4 minus 3 plus 1. So what happens here is, okay, it becomes 2, but okay, we are getting the next greatest element for the 60 is at index 3. So 4 minus 3, which is 1, we are having 1. So for the 70, the next greatest element is at 80, and we get 3 minus 2. So okay, the index itself handles that, so we don't want to add plus 1 at all. So for this case, for this 70, the next greatest element which is at index 1, so we can say 3 minus 1, which is equal to 2. And for this 75, the next greatest element which is at index 1, so the current index for 75 is 5, and the greatest element which is at the index 1, so we just subtracted, so 5 minus 1, which is 4, so we get our answer. And for this 60, the next greatest element which is at index 3, so the current index is 4, 4 minus 3, we get 1, and which is our required answer. For this 85, so the next greatest element is 100, and the index is 6 minus 0, which is 6, so we get 6. And similarly, what we can to do is, so this problem reduces to finding the next greatest element for current stock. So how can we find this next greatest element? Obviously we can make use of stack here, and we also need to store the index, so we can use our stack to store num comma index to be a pair. So if we find the next greatest element at the top of the stack, we can easily compute the current index minus the previous index, minus the top of the index which is on the top of the stack. What if the stack is empty? Consider we are at this index, we consider we are having the 100. So since the stack is empty, if stack is empty, so the current stock is the greatest stock, so and everything is smaller than this current stock, so obviously the total number, if stack is empty, the total number, if stack is empty, we can say total count is put in res, is pushed into res, or we can say it as total count is returned. I will give another example why it is so. If we are considering there is a stock price of 200 here, so the price which is less than or equal to 200 is every price before this 200. So obviously if there will the stack will be empty, so we can definitely return the total count. So basically we can use stack to implement this. So what we can do is, first we can see if the stack is empty. If the stack is empty, we can just return the total count, and what we have to do is we can push the number comma index if the stack is empty. Else, if the stack is not empty, what we can do is, while stack is not empty, and end, the stack dot num is greater than, is lesser than this, lesser than or equals to the current price, current price, then we can just pop that stack. So this is what basically we can do. So this is our algorithm. So we want to find the next greatest element, and for this the prerequisite for this problem is we can you can solve the next greatest element using stack. That will be a good practice for this problem. So first what we can do is we can have a stack here. I will going to store a struct stock. I will say it as stock, and I will define this stock here. So struct stock is nothing but int stock price and int index. So this is going to be my index initially. So I should also have another current index which is going to increment my current index from 0. So current index can be set to 0, and I can get the total count by saying current index plus 1. It will be easy. So whenever this next price is called, what I can do is I want to eliminate the price which is lesser than or equal to from the current price. So while my stack is not empty, and if my stack dot top dot stock price is lesser than or equal to the current price, then I don't want that particular stock, so I just pop that stock. If my stack is empty, then what I can do is, sorry, if my stack is empty, int return answer. So I will say it as answer is equal to initially 0. If my stack is empty, then my answer is nothing but my current index plus 1. Else if my stack is not empty, then answer is nothing but stack dot current index. I think I can start from, okay, it should start from 0 only. So the current index minus the stack dot top dot index. Answer is nothing but I'm just finding the current index minus the top elements index, top price index. Now at the end of the day I'm going to return the answer, but before that I want to push the current price with the current index into my stack. So stack dot push of price comma the index is nothing but the current index, and for each and every time I'm going to increment my current index as well. So this is what is going to happen, and this is not an order of n square solution. We are finding just the next greatest element using stack. So let us try to run our code. Okay, we are getting some wrong answer. Let us check what happens. Sorry, this is typo, empty. Sorry. Okay, it gets accepted. Superb. Let us try to add one more stock price, so that it can be an example for our answer. So I'm adding 200 in our case. If there is a 200, then my stack will definitely be empty, and my answer should be 8. Super, it gets accepted. So let us try to submit our code. Superb, it gets accepted. Hope you like the solution, and the time complexity for the solution will be order of n, and the space complexity is also an order of n. And the prerequisite for this problem will be on x greatest element using stack. It is a pretty simple problem. Hope you like the solution, and let us see in tomorrow's LeetCode daily challenge. Until then, bye.